Welcome back, ladies and gentlemen. Mr. Callan here to help you with Chapter 3, Lesson 6, two-step equations. It's about time. It's about time. See, here's what we're going to do. We're going to take everything we've learned from our one-step equations, and we're going to use those same skills with two-step equations. However, as you can imagine, two-step equations, it's going to be more steps. See, we need to get rid of not one, but two terms to find out what h equals. Left equation, we need to get rid of not one, but two terms to find out what f equals. Naturally, ladies and gents, as you can imagine, two-step equations will turn to 3 and 4 and multi-step equations, but for today, we're going to focus on two-step equations. Now, go ahead at this point, whatever the date is and whatever the assignment is, title your paper, get ready for some notes, come on back when you're ready. All right, ladies and gents, some of you have a strong algebra sense. You're able to model equations. Others of you, this needs to be a challenge for you to dig deeper. Don't just do certain operations because your teacher tells you to. Understand what an equation means. Now, in this particular case, I use big old circles for my x's. You can pretend those are envelopes of money, and as you understand, a variable means it could vary. You don't know what that is. It's a missing piece. So on the left side, we have 3 envelopes of money and we have 7 extra positive dollars. Notice that is why I chose to use the plus symbol. Meanwhile, on the right side, if we add 3 x's plus $7, it's going to be exactly the same as $22. As you can imagine, if it's a positive, I'm going to write 22 plus symbols over here on the right. Okay, so if I were to rewrite this with numbers and symbols, 3 envelopes of money, $7 is exactly the same as 22. As you can imagine, our goal is to find out what x is. So let's go ahead and say, well, if we need to isolate the variable, we need to get rid of that $7. See, I don't really want the extra $7. Now, some people just cross them off. I'm more of a fan of writing 7 minus signs. Oh, wait, Mr. Callan, anything you do to one side, you must do to the other. So I'm going to put 7 minus signs there. And the reason that works is because every positive and every negative cancel out, make 0. Positive 1 and negative 1 make 0. Positive 1 and negative 1 make 0. And you'll see that all those cancel out. And we do have some 0 pairs that cancel out on the other side as well. Now, how do I write with numbers and symbols what we just drew out? Well, we put 7 minus signs on one side, we put 7 minus signs on the other. So let's go ahead and take away 7. Some people just cross them out, but I like to put minus signs. Now, why does that work? Because 7 positives and 7 negatives make 0. And so, if you look at the picture, the only thing remaining on the left side is 3 x's. And if we had 22 and we took away 7, we have 15. Now again, don't forget, ladies and gents, our goal is to find out what x is, not what 3 x's are. So what should we do now? Well, as you can imagine, what we're going to do is we're just going to split up everything that remains into 3 groups. And according to the picture, each of those x's matches up or is equivalent to positive 5. Let me show you how we do write that with numbers and symbols. What we're going to do is we're going to split up or divide each part of the equation into 3 parts. Why does that work? Because 3 x's split into 3 parts makes a single x. I'm going to stop writing that 1. And 15 split into 3 parts means, you guessed it, 5. Now, as always, you see problem, you see work, you see a solution, but you know what's coming. We're going to have to check. So let's go ahead and nab this equation, the original equation, rewriting it, 3 times some number x, 3 times some number x, add 7 equals 22. But we don't think x is unknown anymore. We think we know what x is. We think x is 5. So we're going to substitute it in. Some people even put a little question mark here. And now, as you see, this is why order of operations is so crucial. Do not add 5 and 7, ladies and gents. That's not just a single 5. That is 3 5s. That is 15. And now if we were to add, some of you stop right there and write a check mark. I'm going to go ahead, 15 plus 7. In fact, I would even recommend some of you take your finger, take your hand, cover up that side of the equation, compute the left side. 3 5s is 15, 15 plus 7 is 22. and then look to check. You bet this is a true statement. So I've shown you pictorially how to solve an equation. Get rid of the 7 pluses with 7 minuses. In red, we use numbers and symbols, subtract 7 from both sides. And then pictorially, what we do? We split everything up into 3 groups. Notice the green. We're going to divide both sides by 3, and that leaves us with a single x. Problem? Now 2 steps for the work. Still have a solution, and of course our checking. All right, let's see how we do with another example. In this case, we have not 1, but 2 x's. Now, we have a minus 8, so I'm going to change that to 8 minus symbols, all right, equals 12. Here's the thing. We just want to know what the x's are. Our goal is to get x by itself. We don't want that minus 8, so what should we do to both sides? Now, I can't just cross off minuses on one side when I don't have any minuses to cross off on the other. So, what is the opposite of a minus? What is the opposite of a negative? We're going to add 8 positives to one side. And then be fair to the other side. Let's go ahead. 1, 2, 3, 4, 5, 6, 7, 8. Again, how would we write that with numbers and symbols? If we have 2x's minus 8 on one side. Let's add 8 to one side. Let's add 8 to the other side. Why does that work? Because plus 8 and minus 8, plus 1 and minus 1, plus 1 and minus 1, all those make 0. However, on the other side, there's no plus 1s and minus 1s. There are no 0 pairs. So I'm going to go ahead and cross off a minus 8 and a plus 8. As you can see with the picture, the model, we only have 2 x's on the left side, and we have 20 on the right. Okay, but Mr. Callen, we don't want to know what 2 x's are. We want to know what a single x is. So what we're going to do is we're going to split this up, and we're going to split this up. How do you write that with numbers and symbols? We're going to split or divide each side into 2 parts. Now we do that because 2 x's split into 2 parts is a single x. No, you don't have to write the 1. Naturally, 20 divided into 2 parts is 10. So we think that's our solution. We have an answer. Is it a solution or not? What we're going to do is, you guessed it, take our top equation, recopy it. 2 times some number x, subtracting 8, is equal to 12. But we don't think x is unknown anymore, so let's go ahead and substitute what we know, and let's find out if it works. Again, I would encourage some of you, don't let your brain cheat. Cover that up. 2 tens is 20. 20 take away 8 is 12. And look at there. 12 is equal to 12. That is a true statement. All right, if you need, pause, rewind, watch those videos again. Look how pictorially, and I use the colors on purpose, look what happened. We got rid of 8 minuses with 8 pluses, and so I wrote plus 8 on both sides of this equation with numbers and symbols. Then we took everything that was left over and we split it into 2 groups. So we wrote divided by 2 with numbers and symbols. That solved for x. X is equal to 10. And then we took that number and we substituted it in to check. Real checking, not fake checking, not putting in some bogus number, but really checking to make sure it is a true statement. Now I'm going to go ahead. I'm going to invite you, if you wish, to pause the video. Try to work one of these out on your own if you wish. Come on back when you are ready. All right, so meanwhile, let's take a look at these couple examples. If you wish, you can draw a picture. I'm not going to this time, but I am going to remember what we had. I'm just going to kind of put it into my mind. So 8x's and then 5 minuses equals 59. What's the first thing we're going to do? Let's get rid of those 5 minuses. How do we? Well, we're going to get rid of 5 minuses with 5 pluses. As long as we're fair to both sides, add 5 to both sides, we've kept the equation fair and balanced. That leaves us with 8x's on one side, and 59 and 5 makes 64 on the other. Okay, but I don't want to know what 8 envelopes of money are. I want to know what a single envelope of money is. So let's go ahead and divide both sides by 8. In this case, x is 8. Or is it? Maybe I made a mistake. We're going to take the initial equation, recopy it, but now we know what x is, or we think we do. If you need, cover up one side of that. Oops, my bad. If you need, cover up the 59. Now in this case, 8 times 8, 8 sets of 8, you guessed it, is 64. 64 minus 5, well, hello, that works. So we have solved, problem, work, solution is circled, and we have checked our work. Let's do another one, and as you're doing this, look at how these two problems are similar, look at how they're different. Obviously, they have different numbers, they have different variables. Here we get rid of 5 minuses with 5 pluses. Here we got to get rid of 5 pluses. So we're going to take away 5 from both sides. That leaves us with 12y's equals 120. Again, different numbers, different variables, but what do? Here, we had to split it into 8 groups. Here, we split it again, divide again, only now we divide it into 12 groups. Y is equal to 10. Let's check this solution, just like we checked here. Let's substitute in 10. 12 tens is 120, and yes, 120 plus 5 is 125. So you see, I would suggest you see more similarities than differences. Write out the original problem. You have not one, but you have 2 steps to show your work. Circle your solution and then check it using the order of operations. Pause the video, rewind if you need. I got 2 more examples. Now in this case, it's a little trickier because we have not 1, not 2, but 3 n's. Well, that sounds familiar. On the other hand, we have 1 positive dollar and then a little bitty part of a dollar. Over here, we got 4 positive dollars and a little bitty part of a dollar. But we still don't want that $1.80. If we want to get n by itself, we're going to get rid of the 3, sure, but let's get rid of that $1.80. So the first thing we should do is subtract $1.80 from both sides. Now, if you take away 180 from the left, you take away 180 from the right, naturally. Inverse operations cancel out, leaving you with 3 n's. And $4.20, like, I know we haven't pictured this out yet. If you take away $1.80, good, that leaves 3 n's. If you take away one whole dollar and then a part and then another part, okay, all right, I see 2 wholes and then a portion of another, that's 40 cents, 2 and 4 tenths. But I don't want to know what 3 envelopes of money are. I want to know what a single envelope of money is. So let's go ahead and take care of that. Split both sides up into 3 parts. If you split 240 up, 2 and 4 tenths up, it would be 8 tenths, or is it? Rewrite your equation 3 times some missing number, but we think we know what that missing number is. Sometimes I put a little question mark above the equals. Order of operations says multiply first, and then add it up, and it works. One more problem, all right, imagine this. Get rid of that negative $2.30 by adding that $2.30 back in. Of course, we have to be fair. Do that to both sides. That leaves us with 4 F's on one side. That's the only thing not canceled out. Meanwhile, 6 and 5 tenths, 2 and 3 tenths, add those together. But I don't want to know what 4 F's are, so let's split it up. Let's divide both sides by 4 and 4 tenths. Naturally, 4 F's divided into 4 parts is a single F. 8 and 8 tenths divided into 4 parts is 2 and 2 tenths. Take your original equation and substitute in 2 and 2 tenths. Order of operations says multiply first and then subtract, and it works. Again, ladies and gents, you see different variables, you see different numbers, you see different operations, one positive here, negative here. But we're still going to get rid of that constant term first, leaving the coefficient for second. Get rid of the constant negative 2 and 3 tenths, add 2 and 3 tenths, get rid of the coefficient of 4 second. The inverse of multiply is divide, the inverse of multiply is divide. Check by substituting in your number, check by substituting in your number. So now we've gone through 2-step equations. Go ahead and start your homework up, unless if you need a little extra help, I'm going to start you off with problem 41. Now 41, we only have A through F. So let's take a look at A. We have an equation here where we're talking about cost of one book, number of books, shipping and handling, and then is equal to the total cost. So 16 times some number, add some number, equals some number. Now, if I take a look at A, we actually know the number of books, that's 3. We also know the shipping and handling cost, $1.85. We just don't know the total cost. But here we can use our order of operations. See, $16 per book times 3 books, that's 48 bucks. Add $1.85. And very quickly, it's simply just an order of operations problem, $49.85. We have solved for the missing piece for part A. On the other hand, if we take a look at part C, now this is interesting. We don't know the number of books. We do know shipping and handling was $345. We do know the total cost was $99.45. Now, I would argue that this is a two-step equation, and that if you use the steps similar to what we just did, you're going to get rid of that shipping and that one-time shipping and handling cost, subtract that from both sides. Then you're going to divide and get rid of that. You can solve this using the steps that we just did. All right, one last problem to review. Let's take a look at problem F. Now in problem F, we actually know the number of books. It's 7 books. We do not know the shipping and handling charge, and they give us the total cost. Now, if $16 a book times 7 books, that gives us 112. I would argue from here that you're going to be just fine solving and finding out what that shipping and handling cost is. Don't forget, you may use the commutative property to flip that equation around, and you should know what to do from there. All right, folks, here is a challenge. I would argue it's a challenge. Some of you are going to pick up on it somewhat, quite well. Others of you, it's going to take some practice, just like many things. So take your time, rewind, watch the videos again, go back and look at the models if you need. I will be pushing you to draw models in the next couple days. All right, that's what I got for you, folks. Take care, do well, and let's grow.